Alright, so here we have a very popular identity, sometimes seen in Calculus 1 and Calculus 2, where it basically tells us that the integral of dx over x squared plus 1 is equal to arctan x plus c. Now in this video we're going to be looking at how we can quote-unquote prove this identity, because on formula sheets sometimes it never tells us how we get arctan x plus c. So I guess one of the most easiest ways to actually prove it is to solve it from scratch. So something that we can notice here is that we just have to look at this part over here, which is our denominator. We'll see an x squared plus 1. Now an x squared plus 1 kind of looks very similar to if we had this, right? This is a Pythagorean identity. If we had tan squared theta plus 1 is equal to sec squared theta. It's very, very similar. So if we connect this, we can kind of see that this tan squared theta to our x squared plus 1, we'd see that the tan squared theta would actually be x squared. So then tan theta can actually be replaced for x, right? So then therefore my x would be equal to tan theta. Right. Now, we also have a dx, right? We also have a dx. So if we were going to do a substitution, we would basically get that our dx, right, is going to be equal to the derivative of tan theta, which is sec squared theta d theta. Now we can rewrite this integral in terms of our trig sub that we made here. So let's rewrite this. So we would have the integral of dx over x squared plus 1 equaling the integral of sec squared theta d theta, as we have a dx on the top, right? We can see we have a dx on the top, and at the bottom we're going to have tan squared theta plus 1, as remember x is equal to tan theta, right? And it'll just be x squared, so tan squared theta plus 1. Okay. Now, if we look to this identity, right, which we wrote over here, we see that tan squared theta plus 1 is sec squared theta, right? So if I have a tan squared theta here plus 1, all we're going to be getting is the integral of sec squared theta divided by sec squared theta, right? Because we have a tan squared theta plus 1. That's equal to sec squared theta. So now this is simplified into sec squared theta over sec squared theta. And we can't forget our d theta. So this is just going to be simplified into the integral of d theta, right? And that's just going to be theta plus c, of course. It's going to be equal to theta plus c. So what are we going to do from here? Now, this is written in terms of theta. We don't want it to be written in terms of theta. We want it to be written in terms of x. And we can remember that we set our x equal to tan theta, correct? And this kind of tells us that theta, therefore, must be equal to tan inverse of x, or we can just write arctan of x. So therefore, if we replace this arctan x for theta, and we have a plus c here, right? So we can finally state that our integral of dx over x squared plus 1 is going to be equal to arctan of x plus c. So we kind of proved this with trig sub. I hope this helped. Have a good day.